Good day, ladies and gentlemen. My name is Refentse Molehe, and today I'll be introducing you to two of our new spiral concentrators. So I thought a good place to start will be just touching a little bit on the principles of how gravity concentrators work. So this will be a little bit more on a high level. So as we know, gravity concentrators separate based on density. So it heavily relies on gravity for separation to take place. You will always have to identify what your valuable mineral is and what your gangue mineral is. Once you have those, then you have to just determine what the density is between those two minerals. You kind of actually expect to have a density difference between your valuable mineral and your gangue mineral. A couple of ways to check it is if you put the material on the spiral, typically through visual inspection, you should see a separation take place. Alternatively, you could use the ratio criterion, which I have included here at the bottom. There are other factors that influences how separation takes place, or mainly how efficient your spirals are. We've spoken about just generally the mineral content, meaning your valuable and your gangue mineral. We also looked at the specific gravity, which will be having a density difference. But the main one that I want to focus on today would be particle size. When you look at the different types of Multotec spirals, you'll see that the particle size range actually has a top size mainly of around 1 millimeter. And then it also has a bottom size of 45 microns. So as a rule of thumb, we say that if your material has more than 10% passing at 45 microns, desliming is required. And this is also to assist with not only efficiency, but to avoid viscosity problems. So if you look at the first bar at the top, typical spirals has a top size of 1 millimeter, as I've mentioned. But what we've seen is that there is a little bit of a restriction to how performance takes place based on particle size. So what we at Multotec have developed is two new spirals that actually works on the two extremes of that particle size range of below 45 microns, or bottom size of 45 microns and a top size of 1 millimeter. The first spiral that we'll focus on would be the ultrafine spiral. This ultrafine spiral focuses more on having a top size of 150 microns. The second spiral that we will look at is the AC25, which focuses on coarse material. So what do we refer to as coarse material? That's material that has a top size of 3 millimeters. So like I mentioned earlier on, depending on your particle size, there's a difference in performance on the spiral. What we've seen at Multotec is when you narrow down the size fraction, there's actually performance efficiency improvement on the spiral. And this actually heavily relies on the increase of surface area. So let's look firstly at when you have an ultrafine material. With the ultrafine material, what typically happens is that there's misplacement that takes place. So what do I mean by that? When you feed your material into your spiral, you expect that you will have your concentrate, middlings, and tailings. But what also happens is that your high-grade material that's very fine, let's say below 75 microns, ends up moving with the water and reporting into your tailings. This creates a band referred to as slimes. When you actually analyze your slimes or your tailings product, you'll find that you still have high-grade material. So for example, you'll have high-grade chrome reporting into your tailings. And as we know, your tailings is material that you typically discard. So what we're trying to achieve with the UX7 is to have less material reporting into your tailings, that's high-grade chrome, and more of it reporting into your concentrate. So we were able to achieve this with the ultrafine spiral, which is the UX7. So where is this UX7 typically or more applicable? So the main basis would be having a top size that's at 150 microns. Other places or other areas where it's applicable is when you're reprocessing your tailings dams, when you are considering if you've already done a full flow sheet of spirals and then you have that tailings that's being discarded, typically you would have your high-grade chrome. You also want to reprocess that. So any material that will typically go into your tailing storage facilities, and it's also a good alternative for other technologies such as shaking tables. And the main basis is that the top size is at 150 microns. So the operating parameters for the spiral is at solids concentration between 40 to 60%. It has a capacity range of dry tonnages between 3 to 7 tons per hour. But what we've also seen is that it can be pushed up as high as 9 tons per hour. So the commodities where this is applicable is heavy minerals, chrome, and we've done quite extensive work as well on iron ore. So when we look at this slide, it actually focuses on the results of comparing desliming and undeslimed on the UX7. So we know typically that you will deslime your material at 45 microns when you have a standard particle size range. But with the UX7, because the top size is 150 microns, if you deslime at 45 microns, you're practically removing half of your material. So with the test work that we've done, we've seen that the sweet spot for actually desliming with the UX7, or when you have a top size of 150 microns, it will be at 10 microns. So when you look at the results, we've done a comparison between undeslimed and deslimed. We saw that there are some clients who still prefer not desliming the material, but even with that, you still achieve good recoveries. But we've seen that if you do decide to deslime material, there's actually a higher recovery that you'll be able to achieve. So we highly recommend desliming, but not desliming is still an option. So this is just a few of our installation bases where we've put in our UX7 spiral. So it's different mines within South Africa and some of our international clients, including Canada, Australia, and India, to just name quite a few. Now let's move on to our course material. So when we look at our course material, that will be material that's above 1 millimeter microns. When we put such coarse material on a spiral, we find that beaching takes place. What do I mean by beaching? As you can see in this image, this is when your material stops moving and just settles on the surface. So you want to avoid that. And we were able to actually see quite a lot of improvements using the SC. The other benefits of the SC25 is not that it only is able to take high or big particle sizes or coarse material, but we've seen as well it's applicable when you have very dense and heavy material. And these are materials typically that you'll find such as ferrochrome and ferrochrome slag. So just to touch on the operating parameters for the spiral, it does the top range of 3 millimeter. So even with the 3 millimeter, you can keep your material all the way down to 45 microns, but we've seen that when you narrow the size fraction to a range of between 1 millimeter to 3 millimeter, we've seen better recoveries on your material. So the solid concentration is between 30 to 50%, and it does capacity range between 1 to 2.3 tons per hour of dry tonnages. Like I mentioned, this material, not only is it able to take particle sizes that have a top size of 3 millimeter, but we've seen it work very well for ferrochrome slag, and other materials will include heavy minerals, chromite ore, iron ore, and even your e-waste material. So I just put an example here for ferrochrome slag to show you the improvements that can be achieved with a SC25. So when we use our standard spirals that we have, we find beaching take place. But when we use the SC25, no beaching takes place, meaning no settling of material happens on the surface trough. So we fed the material at a feed grade of 27% chrome. And for this specific client, they were actually aiming for anything above 40% because that is what's considered as the sellable grade for chrome. But just through running through 2 stages, we were able to get the final concentrate to 50.6% chrome, which is actually quite high. And we were able to drop the slag grade from 71 to around 9%. So the client was very happy with this because like I mentioned, when you use standard spirals, because of how heavy ferrochrome slag is, the material settles on the surface trough. But when you use the SC25, no settling takes place, and you're actually able to reach above the sellable grade of 40%. So this is just also an installation base for SC25. We've installed in quite a few of our South African mines, which include the Mpumalanga area, the Northwest, and Gauteng, Krugersdorp, and as well some of our international clients for test work, including Canada, UK, as well as Zimbabwe. So to round off these two spirals, what we've seen is that with the UX7, we're able to process material that's ultrafine. What we consider as ultrafine is below 150 microns. And with the SC25, it's able to handle very coarse material to a top size of 3 millimeter. The biggest difference between these two spirals is the geometrical changes we're able to achieve in both these spirals. So we've seen that with the UX7, when you have ultrafine material, you require more of a shallower spiral. And for the SC25, when you have coarse material, you need a more steep spiral to assist with the flow of the material. So that is all from me in introducing our two new spiral concentrators. Thank you.